I am Aritra. I am currently assistant professor in Indian Institute of Technology, Madras. And this work is done when I was postdoc in University of Cambridge with my Cambridge collaborators, and part of it is done in IIT Madras as well. And the topic that I'm going to present today is AI-powered application for construction schedule management using natural language. And the paper is co-authored by Dr. Danny Murguia and Professor Campbell Middleton from Cambridge. So we all know that global construction demand is growing, and the statistics shows that $94 trillion is going to be invested in infrastructure alone in next few years. But when you look into the situation, what we are doing, and I think it is known to all, and we are not doing great. So we have delays, we have cost overrun, and this is the statistics from India that it is showing that around 560 projects out of 1,700 mega projects are delayed, and then the cost, accumulated cost, is around 4.4 trillion Indian rupees. So it's a huge amount. But when you look into these problems, one of the major problems that people are highlighting again and again is poor schedule management. So if you see statistics presented recently, 68% of the people believe that poor schedule management is a problem. So what we can do to improve the schedule management process, that is one of the research questions that we tried to solve in this paper. So if you see a typical project schedule, I think you all are aware of this kind of things. So basically, you have a schedules. It's a complex schedule. You have project name, WBS, and then activities, and you have a lot of bar charts and things. So who can interpret that? Of course, definitely people who are in this field, who are expert of analyzing schedules, or especially planners, schedulers, planning engineers, project managers, they can do it. But they are not the people who are actually controlling the schedule. The schedule is controlled by last planners who are at site. A lot of the times, it's difficult for them to understand the schedule, and if they want to learn, the learning curve is also quite steep sometimes. Another challenge is, especially in small and medium-sized companies, it's often not, these licenses are so expensive that these kind of softwares are not given to everyone to use. So people are actually using like paper-based schedules that they're given from the project sites, and they just follow those schedules to execute their task. And what happens many a times, these schedules are often outdated. So once they get the schedule, they cannot go back to office to get the new schedules, and then the schedule what they are following is often not the up-to-date schedule that they're supposed to get. Many companies or many software companies have started this apps which are actually taking those schedules to site through apps. But still, if you take those schedules, you also need some expertise to understand those schedules or fill those information. So in this particular topic, what we are thinking that how can we democratize the access of schedules to everyone so that we can control the schedule from the very last mile in the construction site. So we came up with a simple method which is based on like where we can use language models and graph networks, so where we can actually integrate information and make it accessible to our project people. So the thing is, here we can actually insert any schedules in any format, so can be several other formats, and then these informations are actually converted and stored into a graph database, and then we use language models to access and query those graph databases, and then finally deploy those information through a web-based system or application-based system where user can actually interact with the schedule in natural languages. So in further slides, I'll show some of the examples that we developed, and definitely there are a lot more things to be improved in this case, and we are working on that, and we'll love to get your feedback on this. So the first thing is, definitely if we see the schedule is already a graph structure, so you have a project, then you have different phases or WBS of the project, then within those projects you have different activities. So this is one kind of parent-child relationship we have. And another set of relationship that we have is the sequencing of activities. So you have predecessor activities, you have successor activities, you can connect them. So what we tried actually, we used these WBSs as one type of node, and then activities as other type of node. And then this hierarchical relationship, we presented them using this has relationship. So WBS will have activities, And then we have successor relationship which will actually show the sequence of activities. So then you can actually have a nice graph, and each graph node will actually contain all the information or attributes related to that particular activity. So for example, start date, end date, and then critical path, and other activities. And you can actually improve this with other input as well. So this is, once we convert these schedules into graph, so this is how it is actually looking like. So we have a construction, so you can actually have other WBSs, and then if you go further, you can get WBSs and activities, and then if you go further down, you will get further more WBSs and then activities. And then on the right hand side, you can also see, if we click one of the WBS or node, you can also see different attributes that the graph is containing. So in a way, all the information that we need are actually stored in this graph database, so that you can actually use graph query language or even simpler tools like LLMs to extract information from these graph databases. So the next thing what we tried is we tried to deploy this through a web-based system so that we can reach out to people easily. So as planning engineers or as planners, you don't have to print those schedules and give it to every individual. So what you can do, you can upload your things in a server, and then people who are working at site can actually access that through this server system. So this is one of the preliminary study we did. So you can actually choose your language models, and basic things that you can directly extract from schedules like critical path. You can directly get the list of critical activities along with bar charts. And then some of the basic things like look ahead plans, what you would like to do in next 3 days. You can actually select look ahead plan by yourself and get those look ahead plans. For example, 3 days, 7 days, 15 days, whatever you want. And then you can also get to know that what are the tasks I'm going to do. It can also be interactive. So for example, instead of just getting those information which is there in the system, instead of getting those, you can also interact with the schedules. So for example, here you can just ask question to the schedule. So for example, I am a rebar worker. I work fixing rebars. So I just want to understand that what all my activities I am supposed to do in this construction. So you'll just ask that give me a list of rebar tasks. So it will actually give you the list of rebar tasks that you are supposed to do along with your start date and end date. So the person who doesn't know about schedule can also get to know about what he is supposed to do and when he is supposed to do all this information. So how it is happening, so I'll just pause it here. So basically what is happening, if we use this graph query language, so what it does, basically it takes human input and these large language models actually converting those human inputs as a graph query language, for example, Cypher in this case, and using this Cypher language to go back to the graph network, graph database, and extracting information from that, and it's giving you in a nicer way and easier way to understand. So one more thing we tried is basically validating this thing, whatever the model is extracting, whether we are getting the correct thing or not. Definitely we tried to copy that graph query language and the Cypher command from that and put it back to the Neo4j, and we could see that this is actually giving us the same result that we are getting. So in a way, the result we are expecting, we are getting in that way. So it can be useful for our workers. And the next thing we tried a few other things, for example, extracting specific information related to activity or WBS. So it can also give you the duration of the activity that you are looking for or that you are going to work on. And so several other things like I would like to know when the start date of this activity and when the finish date, cost, completion ratio, and all these things. So these are the things already available. Precedence and succeeding activity, definitely you can know what is your next task. So for example, as a contractor, you finish this part, you would like to know what will be your next task you are supposed to do. So you can directly get those information, and you can also cross check in the schedule also it is there. Similarly, succeeding activity, what is the, that was a preceding activity and these are succeeding activities. You will also know this task I have finished, what I am supposed to do next, that you will also get. So after finishing this exercise, we reached out to some of the professionals that who are using them extensively in their projects, and we tried to get their opinion. Although our sample size was very less, only 5 people we tested. And they found it, in some cases, it is actually giving us low effort to extract some of the information, okay? And one of the potential things that we are seeing, that if we would like to improve this in the further. So they asked us to improve, can we update the schedule by manual like human language input? So that we are working on. So for example, they say, I would like to update my schedule by saying that the third floor column rebirth time is 50% completed. So the information should go to that particular activity and the node should get updated. Okay. So while trying that, we could develop some of the things, but one of the things, this is not backward possible. That means I cannot take the graph and go back to other schedules and update that, but definitely the graph can be updated using this kind of information. Okay. Then we are also trying to integrate with building information models. So in our previous presentation, we have seen that people have converted building information models into IFC graphs. We are also trying how can we integrate two different graphs coming from IFC graphs and coming from schedule graphs. How can you merge them and get a 4D so that you can also get the information related to project update in your project information in your 3D model as well. And the third thing, we are also trying to deploy it through mobile applications. So as of now, it's locally hosted. So if we can make it mobile, so those who are working at site, they can directly access it. So that is also some of the exercise that we are doing now. And so far, this has been done. And thank you for listening. And here are contact details if you have any further questions. Thank you.